through 22.
Okay. Can anyone tell me what they are?
So it says write the first four terms of the sequence.
Yes.
With
the general term. Is this an negative 1 to n plus 1? Is that the one?
Yeah.
Very good. 2 to the n minus 1. So we want to determine the first four terms. All we have to do is say when n is 1, I determine a1, and then a2, and then a3, and then a4. All I have to do is just substitute. So I have negative 1 raised to the second power over 2 to the first power minus 1, which is 1. So the answer is 1. When n is 2, I have negative 1 to the third power, which is negative 1, over 2 squared, which is 4 minus 1, which is 3. Negative 1/3. That's all I have to simplify when n is such and such. Is that okay? So when n is 3, 3 plus 1 is 4. Negative 1 to the fourth power is 1. 2 to the third is 8. 8 minus 1 is 7. Are we okay with these terms? And then a4, 4 plus 1 is 5. Negative 1 to the fifth power is negative 1. And 2 to the fourth, 16. 16 minus 1 is 15. So I determine the first four terms. I determine the first term by making n equals 1 and then so on and so forth. This is from section 8.1. Is that okay?
Yes.
Okay. So we want to do move on to the next one, correct? Okay. So let's move on to the next one. Thank you. The next one is we're given a formula, recursive formula. So we have a1 equals 4. And we have an equals twice an minus first plus 3, of course, for n greater than or equal to 2. So first, it's wise to look at what this says. I am given the first term already. And I am told that any term is twice the previous term plus 3. Once I understand that, the rest will be easy. If this is term n, and this is term n minus 1, this means that this one is before this one. So if this is a1, to find a2, 2 times 4 plus 3. And so on and so forth.
So you don't plug in like a1 in there, you just plug in what you get from a1? That makes sense.
a2, if this is 2, 2 minus 1 will be 1. So a2 is 2 times a1 plus 3. If this is 3, 3 minus 1 will be 2. a3 will be twice a2 plus 3. Is that better?
Yeah.
So a2 is twice times 4 plus 3. That's 8 plus 3, which is 11. a3 will be twice the previous term plus 3, which is 25. That's what the formula says. Any term is twice the previous one plus 3. Twice the previous one plus 3. Twice the previous one plus 3. a4 will be twice the previous one plus 3.
So like for a1, you would put in
No, a1 is given to us. We cannot make up a1. The formula starts with 2. That's why we are given this condition here.
okay.
You cannot plug in 1 in the formula, because when you plug in, if you try to plug in 1 in the formula, then you have 1 minus 1, which is a0, and a0 doesn't exist. That's why we are given a1. We are given the starting point. Does that make sense? Which part is not clear?
I guess like where's the it's like 2a. Like where do you put it in for a?
Okay.
You're putting a 4 in for a. Okay, I get it now.
For a1,
Yeah.
I put in 4.
Yeah, and then you get.
So an equals twice an minus 1 plus 3. If this is 5, this is 4. If this is 10, this is 9. A10 is twice A9 plus 3. A2 is twice A1, which is given to us, plus 3. A3 is twice A2 plus 3.
So say you wanted to find A3.
Yes.
A, you would put in 25.
If I want to find A3, I have to put in.
No, I'm saying like if you're trying to find A4.
Oh,
you
okay.
You put 25 in for A. Okay.
Exactly. Is that better? Everyone? Yes? Okay, next one. In the next one, we are given 3n plus 2 factorial divided by 3n factorial. And we want to simplify this. Thank you, Wendy. Okay, so if you remember what factorial means, then you will ask yourselves which one is the biggest of these two. And the biggest of these two is, remember, n is a natural number. From 1, 2, 3, 4, and so on and so forth. So which of these two numbers, either 3n plus 2 or 3n, will be bigger?
3n plus 2.
Correct. So then I have to present what 3n plus 2 factorial means, which is I have to start with it. Yes, I have to start with it. Times. Yes. But I have to continue times 3n minus 1, times 3n minus 2. Instead of that, I will put factorial. And I will stop at 3n factorial only because I look at the denominator. And once I look at the denominator, I realize that these two can be simplified. Is that okay? So then when I multiply, I get 9n squared, and then plus it's 9n and plus 2. So 3 times 3n times 3n is 9n squared, plus 3n plus 6n is 9n, and 2 times 1 is 2. Do we have any questions on factorials? Do we have any questions on factorials? Any questions on factorials? Anyone? Is that a yes? Is that a no? Do we understand this?
You're multiplying?
I'm multiplying two binomials by foiling. Yes. Is that okay? Is this
So
okay?
you just go down until you get what was on the denominator?
That's why I started by asking which one is bigger. So then you stop at the smaller one. Exactly.
Yeah. So 3n plus 2 is bigger.
Yes. So that's why we started with 3n plus 2, 3n plus 1 times 3n factorial. And we stopped at 3n factorial. So, okay.
Can we just do another one?
So 4 factorial is 4 times 3 times 2 times 1. So if I have 4 factorial divided by 2 factorial, I will write 4 times 3 times 2 factorial over 2 factorial to simplify it. And this will be just 12. That's exactly what we did, but with numbers now.
So you just count down.
The definition of factorial is n factorial is n times n minus 1 times n minus 2 times dot 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 times 3 times 2 times 1. That's a definition of n factorial. So then when we have, let's say, n plus 3 factorial over n factorial, which one is bigger? Good. So I have n plus 3, n plus 2, n plus 1 times n factorial over n factorial. I can continue expanding this, writing all this, but there is no point. They are the same, and they will be simplified.
And then you would FOIL.
Yes. So first I will multiply, let's say, these two. And I get n squared plus 3n plus 2. And now I distribute the rest.
Okay.
N to these 3. N cubed plus 3n squared plus 2n plus 3n squared plus 9n and plus 6. And then I combine like terms, n cubed plus 6n squared plus 11n plus 6. Is this better? Very good. What is the next one? Oh yes, so we are given a bunch of summations or terms. So we have 4 plus 10 plus 16 plus dot 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 plus 6n minus 2, and they tell us write the condensed form with the summation or sigma notation. You can use any index you want. In other words, you can use I, you can use J, you can use K. It's up to you. Okay. From I equals. From I equals. We have to look here. We have to look here and see how we get the first term. What do I plug in this to get the first term? And that's the starting point. Very good question. Correct. When I is 1, 6 minus 2 is 4. When I is 2, do I get 10? When I is 3, do I get 16? Good. So then from I equals 1 till what is the last possible value for I? Last possible value for I is the last one. Yes. And then what do we have inside? What is the sequence? The general term of the sequence. But we have to use I. Exactly. 6i minus 2. Let's check now. When I is 1, do I get 4? When I is 2, do I get 10? When I is 3, do I get 16? Plus dot dot dot. When I reach n, when I is n, do I get this last term? Yes, 6n minus 2. Yes. Is there another one? Okay, so let's take a look. I'll open the book. And this is in section 8.1, and we can choose from there. You can choose if you want, or I'll choose. 8.1. Any questions? Any questions? Any questions? Yes.
There's lines, like there's a line above that.
Yes, where they want you to put I equals 1. And you're not going to write on the test paper anyway. Don't even look at what is written there. You're not going to write on the.
But I need to know because I have to write.
So you have to write the lower limit. You have to write the index. You have to write the upper limit, and you have to write the general term. Yes. So again, you don't have to look at those because you're not going to write on the test paper. Okay. So let's take a look. Other examples are on page 752 and 753. Yes, Jeremy, are you talking to yourself or?
Sorry. Yeah, I'll stop.
Okay. So any questions? Okay. So let's look at 51. I don't think we did 51, but if we did 51, please tell me and we'll choose another. So this is 51 on page 753. Ready? 1/9 plus, no, that's 52, of course. 4 plus 4 squared over 2 plus 4 cubed over 3 plus dot 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 plus 4 to the n over n. And they're asking us to write the sum. We'll see in a moment if it's 1. Is it? Yes, because you plugged in 1 here, and you plugged in 1 here, and you got the first term. I accept that. Then what is the last one? Depends.
If there's an end.
Depends. For example, I could have here 16 and here 16, then I will stop at 16. So it depends.
Okay, look, if there is an end in the last one, is it always?
But you have to check. Yes, I would say yes. Yes, Jeremy?
Can it be like basically whatever from whatever the first thing is, whatever changed to get to the last one? Is that basically what the top is?
It depends. Some of the terms don't work like that. So I don't want to give a recipe without looking at the example. Okay, from I equals 1 through n, good. From what?
Or
Raised to I, yes,
over
over I, indeed. Let's try it. When I is 1, I get the first term indeed. When I is 2, I have 4 squared over 2. When I is 3, I have 4 cubed over 3. When I is n, I have 4 to the n over n. Excellent.
So what were you saying?
This is basically the easiest problem you have ever had this semester. Would you
I know,
would you
I'm
agree?
serious. Can
Would
you
you agree?
test that? I think we're trying to make it harder than it is.
Yes, I'm sorry, Danielle, go ahead.
But like that's simple, but what are you saying? It won't always be like that.
I have to look at the
Or-
example. I don't want to just give an answer without looking at the
But-
example that Jeremy's has in mind. So I just can't give a recipe without looking at his example. Good. Next question.
Um,
Yes, please, Amanda.
So 23, it says use a calculator's factorial key to evaluate the expression below.
What is it?
50 factorial over 500.
Yes.
Where's that key on the calculator?
Probability. In probability and number 4.
Math probability for.
Thank you. Correct. So I didn't think of saying math, but
Yeah.
yes. So in math, I go to probability and number 4. I just clicked on. So if you want to use, because you have to use the calculator, there is nothing you can do here. So 50 factorial divided by, what is it, 500?
Yeah.
Yeah, you cannot determine this by hand. So please notice that there is an E here. So please be careful how you read this. I would recommend 2 decimals or 4 decimals, it doesn't really matter, times 10 raised to 61. So this is something very big, huge. So 6.0828 times 10 raised to the 61.
And if it was,
Yes,
so you have to write this in scientific notation.
yes.
So all you have to do is times 10 to 61. Like you don't have to do like 0, 0, 0, 0, 0, 0.
Will you put 61 zeros?
Um,
Please don't. Because I'm not going to count them. Good. Next problem. Which one? Okay, anything else that you would like to practice? Any other problem? Anything?
Number 4.
Number 4, what does it say?
Yeah, exponential function of.
Okay, so we are given f of x equals 565 times 1.026 to the x power. Good. And they're asking us from 1975, which is x equals 0. They're asking 2002 will determine x. 2029 will determine x, and 2056 and will determine x. All we have to do is just find x, knowing that 1975 is 0. So how many years from 75 to 2002?
27.
And then, so that's 54. Good. And then, good. All you have to do is plug it in and get those numbers. So in y equals, put in the function, which is 565, and in parentheses 1.026.
Table.
In y equals, You cannot put in table yet. You have to put this in y equals first. So 565, 1.026 to the x power. And I have to go to check table set because the software here always goes back to default. And then I go to second and table and I put in 0, 27, 54, and 81. And I copy the numbers. So we did this problem in class together. So we have 500 and then 1,000 and then 2,000 and then 4,000. So it appears that it doubles. The population doubles. That's all you have to do. So you have to say the population appears to be doubling every 27 years. Next question, next problem, anything else you would like?
Number 5.
Correct, sure.
And I just have a quick question.
Yes.
It's just a yes or no answer. So for the compound interest formula, the n is how many times it's compounded?
Yes.
Okay.
Yes. If it's semi-annually, it's twice a year. If it's monthly, it's 12. And the interest compound, the continuous compound interest is this. PE2. Okay. So these formulas will not be probably will have to be given in the test because I promised you're not going to have to remember those. But they may not be given, for example, in this problem. So you just have to go back and look and copy them. I forgot. You said number 5. Did you say number 5?
Yes, I did.
Okay, so for number 5, it says which function, so let's go to y equals again. Is this okay? So plug it in, plug in f, 6.20, 6.2, and in parentheses, 1.028 raised to the x power. And then the second function is 37.3. Don't forget parentheses for an entire denominator. 1 plus 6.1 e right here. Don't forget parentheses for the power of e with minus the negative sign, not the operation. 0.051x. Close the parenthesis for the power, come down and close the parenthesis for the denominator. And it says x is number of years since 1950, and in 2006 is 56 years. So I have to plug in 56 for both. And if the result is close to 27.3, I will choose that function. So with second and table, plug in 56. And when I plug in 56, the second function appears to be closer to 27 than the first one. I don't know, I couldn't say in general that the second one is better. I can only say for 2006, the second one is better because the number is close to what you see at the top of the bar chart. At the top of the bar chart, it says 27. The first function gives us 29. So that's why I will say function g appears to be better. Does that make sense?
Yeah.
Is that okay? You will have absolutely no difficulties if you would go back and redo the problems we did in class. Yes, anything else? Yes, please.
Number 1.
Number 1, negative 7x plus 1 plus 49. They want us to present this function using transformations. Okay? So,
What number is this? It's not all the packet.
so let's take a look and decide which is the base function here. Is it the absolute value of x? No. Is it x squared? No. Is it natural log 5 of x? No. So Which one is it? There is no base of negative 7. Yes, I want the base, yes, sorry. This is the exponential function, thank you, Deborah. It's exponential function 7 raised to the x power. Now I have to remember which shape is this, increasing on all its domain or decreasing on all its domain. And the base tells me. Yes. Where does it cross for sure? All pure exponential functions, decreasing or increasing, it doesn't matter.
0, 1.
Perfect, awesome. So this is 7 to the x. Good. So now in order of transformations, after I graph 7 to the x, what will be the next step? Awesome. 7 raised to x plus 1, left 1. Awesome. Great job. Next. Not yet. I'm not there yet. Yes. Negative 7 raised to x plus 1 reflect with respect to the x-axis. And number 3, yes. Negative 7 raised to x plus 1 plus 49, indeed up 49. Very good. Awesome. So I graphed the base function. Now I want to graph number 1. And you already told me to shift it left 1. Where does this point go? That's my marker. My indicator, if you want. Left 1, right here. So it was at 0, 1. Now it's at negative 1, 1. Correct? I'm sorry? Not yet. So this is 7 raised to x plus 1. Then you told me to reflect it, which is awesome. That's the correct thing to do. Where does this, my indicator, go? Very good. Right here. So here's the graph. And this is the graph of negative 7 raised to x plus 1. And yes, I have to move the horizontal asymptote from y equals 0 where to? Awesome. 49 indeed. Thank you. Y equals 49. Where does my special point go now? This point. Yes. So it will go to 48. I mean negative 1 comma 48. Correct. So this point will be negative 1 comma positive 48. Here it is. Very good. Well done. So this is the final graph. Negative 7 raised to x plus 1 plus 49. Well done. So now final question. I would like to determine the range of this function. What will you say? To 49 with a parenthesis, because there is a infinitely many numbers between 48 and 49. So then the range, negative infinity to 49. Very good. Good job. Okay, anything else? The problems that you would like to work on?
Can you do number 8?
Yes. Let's look at number 8. Any number. Number 8. Okay, number 8, we have an expansion, which is log base 5 of the 7th root of s to the 6th t over 25. Very good. So they're asking us to expand and fully simplify. Good. So what is the first step?
The square root of 7.
Jeremy's right. I cannot jump to the quotient rule before I take care of the power. Yes, that's the first step. So what is the power when we talk about the 7th root? What power do we have in mind?
1/7.
Indeed, very good. 1/7 log base 5 of s to the 6th t over 25. Well done, both of you. Okay, then at this point, this is what I would do. Of course, if you prefer a different method, I accept it. I see 3 factors. 2 factors coming from the top, they will have plus in front. 1 factor coming from the bottom, it will have negative in front. So 1/7 log base 5 of s to the 6th plus log base 5 of t minus log base 5 of 25. If you do this, you are combining the quotient rule with the product rule and you don't have to go back. Now, is it wrong to say log base 5 of s to the 6 times t and then minus this and then go back and apply the product rule? No, it's not. But I think if you understand this step, then you are going to, when you go backwards to condense, it will be easier, I think. Okay, so final step, I shouldn't say final, I have to apply the power rule here, and I have to determine this. And remember, log base 5 of 25 is a number. And this is equivalent to what exponential equation? We always start with a base, and we go counterclockwise. 5 raised to some, exactly. 5 raised to some number equals 25. And the answer is 2. So all this piece will be replaced by 2. So then we have, and 6 comes in front and distribute 1 over 7. 6 over 7 log base 5 of s plus 1 over 7 log base 5 of t minus 2 over 7. And that's fully expanded. No one can further expand this in any way.
So the test is for sure next class.
Is it?
I'm asking you. I don't know.
Well, because we already talked about it, so I don't know why we're bringing it up again, or is it not clear, or would you have other preferences, or I mean, I'm flexible.
Could we review?
I'm interested. I'm interested in good grades, and but then what about the final exam?
I mean, me personally, I feel like I would excel better if I just had one more day to review and then take the test on Tuesday. But I understand that we have a final in 2 weeks, so.
Well, that's what she said.
Yes.
Is there a way you can make a video of you doing the package?
So what problems from the packet we did not, we